Welcome to the Zika virus example for hypothesis testing for proportion. It says a researcher claims that 85% of Americans think that they are unlikely to contract the Zika virus. The Zika virus is a virus that a few years ago, that if pregnant mothers got it, it was then a deformity to the fetus, and it spread throughout a lot of the South American type of countries and even in parts of America as well. I'm not sure if I think they have figured out a cure or something to prevent those defects now. It says in a random sample of 250 Americans, 225 think they are unlikely to contract the Zika virus. At a 0.01 significance level, is there enough evidence to reject the researcher's claim? So the first thing I'm going to do is find what the claim is. The researcher claims that 85% of Americans think they're unlikely to contract the Zika virus. Since it's a proportion, we are going to test the proportion. So we're going to use for HO and HA the population proportion P. And it says claims that 85% think they are unlikely. So that means that it's going to be an equality. It doesn't say less than, it doesn't say more than, so it's going to assume that it's then equal. Since it's equal, that equal sign is going to go in our null hypothesis. So it's going to be P equals, and 85% is 0.85. So HO is P equals 0.85, and remember, then that's the claim. HA then is the complement. So it would be P does not equal 0.85. In step 2 of our steps for hypothesis testing, we're going to then use HO to assume the claim proportion P equals 0.85. And since the alternative does not equal, that means this is going to indicate that it's a two-tailed test. Our significance level, it states it is 0.01. Next, our rejection criteria. We're going to reject the null hypothesis if our p-value is less than or equal to our significance level, which is 0.01 in this case. Our test statistic formula is going to be Z test statistic is p hat minus p divided by the square root of p times q over n. Remember, you can always look that up on your formula sheet. Now to get our values. We already have what p is. Remember, if you want to figure out what q is, it's 1 minus p, so it's going to be 0.15. Our sample percentages, n, we said, is going to be a random sample of 250. X is going to be 225. So p hat is going to be 225 over 250. Number of successes divided by the sample size. Let's see if that comes out to be a nice decimal to use here. So we're going to take 225 divided by 250, and it's nice, it's 90%. So that's 90%. Our sample is 90%. Let's substitute these values into our formula here. P hat, we said, was 0.90, or you can write the fraction, minus P is 0.85, that's our claim proportion, divided by P times Q, so 0.85 times Q, 0.15, divided by N, which is 250. Again, you can use calculator or technology to do this. So on the calculator, I can go open parentheses 0.9 minus 0.85, close parentheses, divided by square root of 0.85. I'm sorry, I'm going to open parentheses 0.85 times 0.15 divided by 250, close parentheses, hit enter, and there we go. It's going to be 2.214037214. And again, what we can do is we can use StatCrunch to calculate the test statistic and also our p-value. Using StatCrunch, I'm going to go to Stat, Proportion Stats, One Sample with Summary. Our number of successes is given to us, it's 225. Our number of observations is 250. Our hypothesis test for P, H sub 0, P equals, we're going to change 0.5 to 0.85. Our H sub A, we're going to leave as the not equal sign. We're going to change that, but we're just going to leave it for this case. I'm going to go down and under optional graphs, check the p-value plot box, and I'm going to hit compute. Remember that with this, I like to just go over here to the right arrow at the bottom, and I can then see that it's a two-tailed test, and our z test statistic is 2.214, just like we got, and I'm going to write down our p-value, 0.0268. Go ahead and copy that graph now onto your paper. So our graph, our horizontal scale, remember, is -2, -1, 0, 1, and 2. Our our z test statistic is 2.21. So z equals 2.21. Mark that cutoff mark. Remember, we said it's a two-tailed, so it's going to be actually to area to the right, and we're also going to use the z equals -2.21 and go to the area to the left. The p-value is the combined area in those two tails, and that's going to be 0.0268. 0.0268. Now, according to our rejection criteria, we have to figure out our decision. We reject if our p-value, 0.0268, is less than 0.01. I'm going to add a couple of zeros to help us out. So this is greater than, now less than or equals to. So our decision is going to be fail to reject the null hypothesis. Fail to reject the null hypothesis. Now let's look at our conclusion. This is our other type of conclusion table. So remember, our claim was with H sub 0 because it contained equality. It was actually equal to, and our decision was fail to reject. So we go down in our table, we look at our first column, and we look at our second row, and it says the sample data does not provide sufficient evidence to reject the claim. So we're going to write that down. So we can say the sample data does not provide sufficient or enough evidence to reject the claim. And what's our claim? Well, I did highlight it up here, so it should be easy to see. Claim that 85% of Americans think they are unlikely to contract the Zika virus, and then we get to say at the significance level at alpha equals 0.01. Okay, and so make sure you have does not or is not, and then reject. So the sample data doesn't have enough evidence to reject the claim that 85% of Americans. So that it's basically, it stands true because that claim still holds true. Okay, here we go.